Before we begin, a quick note. This documentary combines publicly available information with industry reporting and strategic analysis. Some engineering claims discussed are based on company announcements and have not yet been independently verified through commercial deployment. For more than half a century, the semiconductor industry followed one simple rule: make transistors smaller and computers become faster, more efficient, and more powerful. That idea, known as Moore's Law, fueled everything from smartphones to artificial intelligence. But today, that formula is reaching its limits. As chip manufacturing becomes increasingly expensive and technically challenging, engineers around the world are searching for new ways to improve performance without relying solely on ever smaller transistors. According to industry leaders such as TSMC, Intel, and AMD, future progress will likely depend as much on advanced packaging and chip architecture as on traditional transistor scaling. That brings us to Huawei. After US export restrictions limited Huawei's access to advanced semiconductor technologies and extreme ultraviolet or EUV lithography systems, the company faced a fundamental challenge. According to the US Department of Commerce, these restrictions significantly reduce Huawei's access to some of the world's most advanced chip-making tools. Meanwhile, ASML, the Dutch company that manufactures the world's only commercial EUV lithography machines, remains the sole supplier of this critical technology. Instead of waiting for access to return, Huawei began exploring another path. Recently, the company introduced a research concept known as Tao Scaling, an approach that shifts attention away from making transistors dramatically smaller and instead focuses on reducing the distance that information must travel inside a processor. Why does that matter? Modern processors are no longer limited only by transistor speed. Engineers increasingly face another challenge: moving enormous amounts of data efficiently across billions of transistors. In many advanced chips, transporting information consumes a significant portion of overall energy usage. Huawei's proposal is surprisingly straightforward. Instead of spreading a processor across a single flat layer, multiple computing layers could be stacked vertically, shortening communication paths between different parts of the chip. Imagine replacing a sprawling city with a skyscraper. People travel much shorter distances between floors than across an entire city. The concept itself isn't entirely new. Companies including AMD, Intel, and TSMC have already invested heavily in three-dimensional chip packaging technologies. AMD's 3D V-Cache, for example, already stacks memory to improve performance in certain processors. Huawei's idea goes a step further. According to the company's published research, its long-term roadmap aims to create much denser connections between stacked computing layers that are common in today's commercial products. If those engineering targets can eventually be achieved at scale, communication delays inside future processors could be reduced while increasing computing density. However, this is where careful analysis becomes essential. Some headlines suggested Huawei had already created a 1.4 nanometer chip. That is not what the available information actually shows. The company's proposal does not describe a new transistor manufacturing process. Instead, it outlines a system-level design strategy intended to deliver performance characteristics comparable to more advanced nodes through innovative chip architecture. Those are two very different ideas. Perhaps the biggest challenge isn't manufacturing, it's heat. Stacking multiple high-performance logic layers together creates significant thermal problems. Unlike data centers, smartphones have very limited cooling capacity. Unless engineers develop effective ways to remove heat from densely stacked processors, performance gains could be offset by thermal limitations. Huawei acknowledges this engineering challenge, and many independent semiconductor experts view thermal management as one of the key questions that will determine whether concepts like Tao Scaling become commercially practical. So what does this announcement actually mean? It doesn't mean Huawei has surpassed companies like TSMC, Intel, or Samsung. Nor does it prove that traditional semiconductor manufacturing is becoming obsolete. Instead, it highlights an important shift happening across the industry. As Moore's Law slows, innovation is expanding beyond simply shrinking transistors. Engineers are increasingly exploring advanced packaging, chip stacking, heterogeneous computing, and new system architectures to continue improving performance. Huawei's announcement fits squarely within that broader trend. Whether Tao Scaling ultimately succeeds will depend on manufacturing yields, production costs, thermal solutions, and years of additional engineering. Those questions remain unanswered today. But one thing is already clear. Global semiconductor competition is entering a new phase. The race is no longer defined only by who can build the smallest transistor. It is increasingly about who can design the smartest overall system. And regardless of which company ultimately leads that race, the next generation of computing may be shaped as much by architecture and integration as by nanometers alone. I'm Professor Jiang Xueqin. Thank you for watching Jiang Decoded.